Okay, let's continue our discussion of hyperbolas with generalizing the formula. We just looked at a formula for hyperbolas that are centered at the origin, but we want to shift the center now to anywhere in the plane, any point hk that you desire. So for a horizontal parabola, that just means subtracting by h over here. Probably comes to no surprise, right? It looks just like what we did with the ellipse and what we did with the circle. And then we subtract the k from the y. All right, and that gets the translation we want to hk at the center. For the vertical hyperbola, again, the y squared expression will be on the left side. Now we're subtracting the x squared expression. Notice, however, h stays with the x, right? We move the whole y minus k over to here, the whole x minus h over to here. And that gets us the translation that we want. So, the standard form for hyperbola, we take our general form. Of course, the xy term is gone. We've never seen that all day. We're going to have the x squared term. We're going to have the y squared term. X term, y term, constant term equals 0. And we're going to have the requirement that A and C have opposite signs. One will be positive, one will be negative. And as we saw a little earlier, a clever way of saying that is that A times C is less than 0. So if we were to multiply all this stuff out and then multiply each side by a squared, b squared like we did for the ellipse, you would end up with an x squared term and a y squared term, but the numbers, the coefficients multiplying those terms, one would be positive, one would be negative. In this case, it's the x squared that would be negative and the y squared would be positive. Okay, so what can you do now with this introduction to hyperbolas? Here's a problem I want you to work out. Look at this equation and find the center. And tell me, is this equation a hyperbola or is it an ellipse? Right? They look so similar. And we've just studied both of them in this section. So which ones am I having you look at here? Go ahead and work that out. Okay. You should see that the center is going to have that number, 0.5, as its x-coordinate. That is the number playing the role of h. For the y-coordinate, it's negative 3. Did you make a mistake and say positive 3? Remember, it has to be subtracted. K has to be subtracted. So there's our center. But is it the center of a hyperbola or the center of an ellipse? Look right there. This whole side of the equation is a big subtraction problem. Therefore, this is a hyperbola, not an ellipse. For homework, I so happen to have it here. On page 655, 7, 17, 19, 29.